some mathematical statements, logical statements are always true. We call them a tautology. If that statement is false, you call it a contradiction. So logical statements that are always true are called tautology. Logical statements that are always false are called contradiction. Are called contradiction. Okay, tautology and the contradiction. For example, let P be any statement. Then P or not P is a tautology. So if somebody asks you, what is an example of a tautology? You can say that, hey, if I have a statement, that statement or its negation is always true. It's a tautology. You can actually use the truth table because and show the truthness of this compound statement. You just have one statement, so you're going to have two rows. So you have P, not P, and P or not P. Let's take a look at your rows. P is true, not P is false. True or false is true. This is the first row. P is false, not P is true. False or true is true. So as you can see, the values for P or not P is true. So since all values are true, we have a tautology. What about contradiction? If I switch or into and, I'm going to get a contradiction. So let P be a statement. P and not P is a contradiction. Because, guys, when you're claiming something in math, you have to have the backup behind it. What's the proof? How do I prove that? How do I prove my claim? How do I prove that P or not P is a tautology? How do I prove that P and not P is a contradiction? Truth table in this case is the easiest method, the easiest way to prove. P, not P, P and not P. Okay, let us begin. True, false, true and false is false. False, true, false and true is false. Well, it wasn't that hard. We see that the values for P and not P are all false, since all values are false, we have a contradiction. So again, when you're learning about new definitions, always keep one example in mind. What's an example of a tautology? P or not P. What's an example of a contradiction? P and not P.